This week, I came across a video where Matt Wynn and James Shore pair on introducing nullable infrastructure wrappers in an existing codebase.
Line 104. I'm trying to think in terms of...
It provided some insights into the pattern, and I was inspired to practice it more. I present to you a session where I write a tiny application using this pattern and show my current understanding of it. So I have the reference article here on the left. We can have a look at some of the patterns here maybe. And here on the right hand side there is the code. On the bottom here I'm going to run the tests. And at the moment this is the only thing we've got, just a single Python file with some setup to run tests. So I can write a test like this. For example, and we'll see the failure down there. It doesn't it expects 5, but it got nothing. So we can add it like that and it passes. So that's the setup we're working with here. So the application I want to write is something that will change the background on my desktop. So let's start out by creating this a class for the application called something like something like that. And the purpose of this application is to switch the background depending on the hour of the day. So let's document that. So how can we test this? So first of all, I imagine that we create an app, something like this. And then we run the application. And I'm just gonna fake it a bit once we get some basic things set up. So I'm thinking in order to change the background, we can probably run some command depending on our operating system, something like that. So at the very beginning now, just to fake it, I'll have the app run, return the command to change your background. And we can name this test to be something like I can set a background, just to get started. So this, maybe it will return a command something like that. And we'll fake this for now, and we will develop this test to use the testing without mocks strategy. So let's see here, we have a test failure saying that there's no run method on background switcher app, so let's add that. And now this thing is not returning what we were expecting, so let's just return this one. And now it's passing. So obviously this is just faking it. So what we really want to do here is assert that this command was actually run. And for now we just assume that when we run this command, the background on our desktop will change. So to do this with the testing without mocks strategy, we need an infrastructure. So if we have a look somewhere here maybe, we can see that there are 3 parts to this pattern. So we have infrastructure code, we have logic code, and we have application UI code. So this right here I would classify as the application code, which basically coordinates calls between infrastructure and logic. So maybe there's I think the logic sandwich shows this. Yeah, so in the logic sandwich it will look something like this. So code will call infrastructure to do something, then call the logic thing to do something with that input and get some output back, and then write that back to the infrastructure. So this the logic sandwich code I think will belong in the application layer or application part. But anyway, so we need an infrastructure for running commands on a system. And we need, and instead of asserting that run returns this thing, we assert that the infrastructure actually did this thing. So I think I will start with the test to flesh out what I want this to look like. So first of all, this background switcher needs to take an infrastructure as a dependency. So I will call this maybe something like process, system, I don't know. Process is the infrastructure, and we want to use the null version of the infrastructure in the test. So and then we also want to collect events from this process. So I'll just use a list for that to collect events, and then we'll say something like process listen events append. So this will register an event listener on this process object, and whenever there's a new event, this thing right here will be called and append that event to the list. And then I want to assert down here that events is this list, but we'll say something like the event type is we can just name it here, so run, I don't know, and the command is this, something like this. So when we run the application we get nothing back, but when we look at the events we can see that we have gotten this event from the process infrastructure. So I'm just going to look at the test errors now and define everything, and we'll still have a lot of fakes, but we'll flesh it out. So first, process is not defined. Let's define that. Has no method create null. Let's define that. So that should be a static method. None type has no attribute listen. So we call listen on the process. So process must return something. So let's just return a new process for now. And it doesn't have an attribute listen, so let's define that. Event listen. Background switcher app takes no arguments. Right, so this takes the process infrastructure. So this is an infrastructure wrapper for running processes, starting processes on the system. Okay, so now we get the assert failure here. So app run still returns this thing, but it's not supposed to. So let's just do it like that to get rid of that failure. And now we get a more expected failure, maybe saying that events is not this thing that we're expecting, but it's just an empty list. So let's see if we can get this to an event instead. So what we want to do here is to save off this process. And then in the run, we want to do something like self.process.run. That doesn't work because process doesn't have a run, so let's add that as well. And now we're back to the assert failure. So how can we make this more realistic? So in the run, what we want to do is to fire an event saying that this command was run. And we can do that by calling a method that doesn't yet exist, but it will look something like this. So self dot what should we call it? Trigger, maybe? I don't know. Let's call it trigger for now. Let's create the event, which is type run. Oops. And the command is this command. Doesn't work because it doesn't have a trigger. Let's define that. Pass for now. It takes an event. And we're back here. Okay. So let's see. We need to make this process into something observable. So we'll do it in this one for now. So we have a list of event listeners. When we call listen, we append that listener. Like that. And trigger loops over the event listeners. And just calls them with the event. Alright, so now we actually got an event, but it doesn't seem to be quite right. What's going on here? What did we assert? Oh, so the command should be a list here in the test. Like that. Okay, so now we're passing. And the background switcher app, I think, looks correct now. So we have a test saying that the background switcher app can set a background. And it sets a background by running this command on the system. And this looks correct to me. I don't see any fake parts in here. On the other hand, if you scroll down the process, it actually doesn't do anything. It doesn't, when we call run, it doesn't actually execute this command on the system. It just calls this trigger. So we need to write some more tests for the process infrastructure wrapper to make this example complete. But I think first I want to refactor out this event code to something called an observable. So the observable has event listeners, and it has this trigger, and it has the listen. So this is just a pattern for being able to observe something, and this process should inherit from observable. So that still passes. Okay, good. And I think I want to rename this trigger to notify. I think that's a better name. So on an observable, we can add event listeners and when we call notify, those event listeners will be called with the event. Okay. The testing without mocks pattern requires that you can observe what infrastructure wrappers are doing, and the observable pattern is just one way of doing that. So let's flesh out this process to make this more realistic and actually do something. So this is an infrastructure wrapper. It will actually talk to the external world, and in this test we actually wanted to talk to the external world for test purposes if it's feasible, and in this case it is feasible because we can run a command of our choice which doesn't have any side effects, any bad side effects. So what I want to do is write something like, I want to create a process object, and then I want to do process run, and I want to run a command that's not harmful. So let's just run echo hello, something like that. And then I want to search something. So let's come back to that, and let's create this create method and just return a process for now. So how can we assert that a command was run on a system? Like if I run this echo hello command in a terminal, I will see hello outputted to the terminal. In the test, this run, for now it doesn't return anything, so it will have the side effect of printing something to a terminal. So how can we observe that? So one way to do that is to run this code as a separate process and capture the output of that process and assert on that. So it will look something like this. I'll just comment this out. So if we run some process dot check output, we can run. So if we do this, we don't have a subprocess, so let's import that. What we see here is that subprocess is Python's module for running processes, and check output will return the standard out of that process. Perhaps standard error as well, I'm not sure. But anyway, here we can see that we get the binary data, hello, a new line back, which is what we expect from this echo command. So if we want to assert on this, we do binary hello, and we need a double backslash for this, for doctest to be able to parse that correctly. And similarly, so this is what we want to wrap in our process object. So instead of doing that, we want to do something like this. So we want to run Python, and we want to run this C is to execute this script. And the script we want to run is going to look something like this. So first we import our module, TWM. Then we create the process. And then we run something. And the command we want to run is echo hello. So what this is going to do is going to run this Python code in a separate process and capture the standard out. And we also expect this to output hello. And it doesn't. And to make this pass, we should be able to do something like this. No. that not work? So we're running the correct example. What if we raise something? Okay, so now this command exited with something. Okay, so we did end up here. Oh, so here we don't want to do check output because that will capture the output. So we just want to do call, is it? Oh, right. Okay. So we have one failure here, and it's when we do the app run. So now in the application up here, in the test, we're creating a null version of the process, but we haven't actually implemented a null version. So when we do this, we'll actually try to run this command on the system, and this program to change background doesn't exist. It was just an example. That's not how you change background on my system. But here it's trying to run that, and it's saying it doesn't exist. So that's why we need the null version in the test. So let's see. Maybe we can do. Let's comment this out for now. And let's remove this, not needed. Let's remove this and comment out this test as well. Okay, so let's describe a bit what process is supposed to do. Actually, let's do it the other way around. Let's comment out this test for now and finish the infrastructure wrapper. So I believe this is actually passing now, so let's see. Yes, it's passing. So let's describe process. So what does it do? I run commands on the system. Right, and also here I don't want to instantiate process like this, but I want to call the create method. That should work as well. All right. So that's what it does. And next part is to make it nullable, so that we can use it in the application test without having it run commands. So let's say something like the null version of me does not actually run commands. So in that case, we're going to do something like process create null run I do not exist. This will fail because this doesn't exist, and it shouldn't fail. We just expect this to pass and do return nothing. So that's where this embedded stub comes in. Let's see if yeah, the embedded stub pattern. So instead of using subprocess here, we will inject the real subprocess module when we do create, and we will inject an embedded stub when we create null. So let's define this first. So oops. So here we inject the real subprocess module, and here we inject something else. Let's do it like this for now. And we can call self.subprocess down here instead. So let's see, what did we get now? Process has no attribute event listeners. Right, because we need to do observable init. Like that. Non-type has no attribute call. Yeah, so I believe this is in the null example. So we're injecting none here, and when we do this, it doesn't work. So here we want to inject the embedded stub, which we call null sub process, and we create it over here. And now we get a new error, null sub process object has no attribute call, so let's add that. It takes the takes the command, and we're good. So now we have tested that this infrastructure wrapper, it actually runs commands, and the null version does not run commands. And the final thing we want to test is that it reports what command it ran. It's kind of tested up here already with the events, but let's add an explicit test for the infrastructure wrapper, because that's a responsibility of it. But first, maybe we can just bring back this test, and it should all work now. Because we use the null version of process here, we don't actually run any commands, but we can see that we got this event indicating that the process actually did something. So let's add this test here and say you can observe what commands I run. So let's create a null version for now. We need to do it like this, process, and then we need to do process.listen, iterate events, and then run and then we want to assert that events is this list with one event, the type is run, and the command is some command. And just to prove that that works, this is the failure right here. So I want to think a bit about this, if this test is good enough. So in this case, there are two main responsibilities of the process. One is that it can run commands, and we have tested that. It actually runs a command on the system. And the second one is that we can observe the behavior of it, observe what it's doing. But when we wrote the second test, we used the null version. And I'm thinking if this is good enough. So, one thing we could do to try to break these tests is to do something like, when we do notify, we just append something to the event. So let's see what happens when we do that. So both of these tests fail. So this is where I have a bit of a hard time figuring out if it's okay to use the null version in this test or not. Because we can potentially do not pass the same thing here as here. So we want the event to be to report that command that was actually run. And the only way to observe the event that was actually run is to do a test like this. Yeah, I'm not sure, but I'm quite confident that this will work. I mean, we're not doing anything funny here with the command, just pass it to the subprocess and we pass it to the notify. So yeah, but that's one question I have about this approach. If we were to do this for real, so for example, if we create the real one here, create, and then we need to run a command that actually exists, so we can do echo hello. We need to observe that as well. So echo hello. So this actually works, and now you can see that hello was actually printed to my terminal. But now to assert that when we get this event that command was actually the command that was run, I think we need to do something like this to capture hello. The only way to verify that this command was actually run is to observe the output here. But yeah, let's leave it like that for now. Use the null version in this test. Yeah. Okay, so let's go back to the background switcher app. So we have, I think we've got everything in place now. If we were to run this app, this command would actually be run. So one last thing I want to do here is to say something like I can be instantiated, saying that the background switcher app create should return an instance of this thing. What am I doing? Static method create return background switcher app with process equals the process create. Right, and I just want to say something like we get something back, this doesn't crash, so this instance background switcher app, and that should return true. Yes. So just to test that this create method works. So just to test this for real, in the main here we can do something like let's import sys as well, and say if sys test sys.argv, then we do this. Otherwise we do background switcher app create run. Okay, so my command here failed, but let's see if we run the background switcher now. It will actually try to run this change BG, and if we run it with the test flag, it should run the test as it did before. Okay. So what have we got now? We have the app, we have one infrastructure wrapper for process, so we can run processes, and in In this test we can observe that processes, the correct processes were run without actually running the processes. And in the process infrastructure wrapper we have test that saying that testing that it actually does something, what we call it. Testing infrastructure wrappers for real is not always this easy. So imagine, for example, that your infrastructure wrapper is talking to an external system, so you would need a connection to that system and you need everything set up properly so you can talk to that system. Fortunately for us, running a command with no bad side effects wasn't that hard. So what's the next step? The purpose of this background switcher app is to set different backgrounds depending on the time of day. So somewhere down here we can not hardcode morning, but we need to do different images for different times of day. And so we need some a new infrastructure wrapper for something like a clock, where we can get the time of day. So let's start with a new test up here in the background switcher app, and try to flesh out what that test would look like. So I'm just going to copy all of that and say I set a different background in the afternoon. So I want to assert that it sets a different image, and somewhere we need to configure this test to simulate that it's afternoon. So let's introduce a clock. Clock is an infrastructure as well, so we can say clock. We can create a null version of the clock, and we can simulate here that the time of hour of day is in the afternoon. So something like that. So let's see if we can flesh out some of this. So first of all, let's add it down here. There's no class clock. Let's define it. Clock. Well, there's no create null. And here it takes an argument which is hour of day. We default it to somewhere in the morning, 9 AM for example. Okay, so now the background switcher doesn't get a clock. So let's define that here, clock. Oh, I need to save it. So now we get a bunch of other failures. So this is where's this? It's in the test. Let's see. Background switcher app. Yeah, so it's in the test right here. So we need to introduce a clock here as well. And in the first test, we say that it's morning. So now we have a test failure here. The second test fails. It expects afternoon, but we get morning. Okay. We can remove this default here. Don't need it anymore. So let's try to fix this. So first of all, we're just gonna fake it until we can flesh out the clock. So let's return a new clock. We're past the hour of the day. This is not what it's going to do later on, but we fake it for now. save that off. And then we introduce a method called something like getHourOfDay, where we just return this. And then in the application, we can do something like this. Save off the clock. And then here we can do if self.clock getHourOfDay is larger than 12, then we do afternoon. Yeah, so now we have this test failing that we can instantiate background switcher app. So here, when we create the app, we also need to pass in a clock. And let's use the same pattern. Clock create. Clock create doesn't exist. Let's add it here. And let's just pass something. Alright. So if we look at the test right here in the app, it reads, it looks quite alright. So we simulate that hour of day is different, and we assert that different images were set as background. This code also looks alright to me. But the obvious flaw right now is that clock is not doing what it's supposed to do. So clock is supposed to be an infrastructure wrapper around system time, so we can get the hour of the day right now. So how can we implement that? So one way we can do that is to use the date command. I believe if we pass format plus %hour, we get the hour of the day. So right now it's 8 o'clock in the morning, my time. So this is one instance where a clock can be a high-level infrastructure wrapper around a lower-level infrastructure wrapper. So the lower-level infrastructure in this case would be the process, which we already have. We probably need to modify process a little bit so that we can observe the output, because right now we can only run commands and there's no way to observe the output. So we can, I would like to try this approach here and see what happens. So let's go back to the test. They're all passing. So let's first work on modifying the process to actually return output as well. So one way to test that would be to say something like I can capture output from commands, and we can test that for real, saying something like process create run command hello and capture set to true. That's the new interface, and we want to get back binary hello new line. So let's see if we can fix that. So somewhere here we have an argument saying capture, by default it's false, and we can fix that by saying if capture we can do I think we can do check output. I don't want to return that. So that works, but so now here's maybe a flaw in the test. When we pass the capture true, we will not get this event because we do return here. So one way would be to test for that as well. For now, I think I'm just gonna do something like this. Because, yeah, I only want to test enough so that we're confident that something works. And I'm confident that this works, so it's good enough for me. So now we can capture output from commands, which the clock would need. So the clock would execute the date command and get the output and convert that to an integer. And if we don't want to do that for real, we also want to be able to simulate output in the null version. So let's add a test for that. We'll do something similar. Let's say create null and responses. And let's do something like that. And it's not what I meant to write. Yeah, okay, so create null got an unexpected argument, responses. So responses is something like this. So we can simulate a bunch of responses. Maybe we can test for that as well. So let's do it like this. So we create a process and then we do process.run first, second. This should be an N. So we configured two responses. So the first time this is called, we're going to return first and then second. All right. Process has inconsistent leading white space. I believe there is. What's going on? Oh yeah, here we probably need this. Right. To make doctest happy with escaping. Okay, so null process has no check output. Need to fix that. Check output. And check output actually returns the output. So here we're going to do return configured responses, and we want to pop the first response. There we go. So now we can call this run method with a capture flag set to true, and then we'll get output back. So let's actually work on our clock now. So clock, we can say, let's see, I know the hour of the day, something like that. And we create a clock. And let's see. How do we want to do this? Get hour of day. Okay, let's see. So I think we want to create a null version. And we want to simulate hour of day to be 5. And then when we get hour of day, something like that. So that should pass. Okay. This passes right now, and let's see if we can refactor this towards a real implementation. So we want to have a process as a dependency. So let's work on that first. Oops. This should not take hour of day, right? So process as well. Let's fake it for now. Do it there. Right. And instead of saving this, let's save the process as well. And get hour of day should be able to do something like return sample.process.run. We run the date command with this plus hour. We capture the output, and then we parse it as an integer. Non-type has no attribute run. Right. So let's see if we can fix this. So in the null version we want to pass a process create null and then pop from empty list. And responses, there's only going to be one response, which is if we want the hour of the day to be this, the output should be something like hour of day, new line, encoded as ASCII. Let's see. Okay, so that works. And now we can probably get rid of the second hour of day argument. Let's see how much fails. Okay. So what we've done here is this should really read I can simulate hour of day. Right. So when we create a null version of the clock, we inject the null version of process. And we configure the process responses to be, the first response will be the hour of the day and a new line encoded as ASCII. And so this is simulating the response of this one. And the real version, I'm not really sure how to test this when we have a high-level infrastructure wrapper. But here we want to say process.create, inject the real process. So let's add a test saying that I can be instantiated. And here we want to say clock. That should be true, yes. So we can create a real clock. Let's make it clear here as well. Let's fix some formatting here. So is this clock finished now? Given that this command actually returns this, we're good now. And I'm not sure if we're supposed to test that as well, or if we're just going to simulate responses from this one. To test it for real, we could do something like this. Create the clock, get hour of day, and we'll get something back. So in my case, I'm getting 8 now because it's 8 AM, but we can't assert that it's 8 because yeah, that will change depending on time of day. So one way we can do is to say that this should be an instance of an integer. Because this is always going to be true no matter what time of day it is. But I'm not sure if in this pattern if we want to write a test like this or not. So let's have a look at what it says about, let's see, here it says, avoid creating complex webs of dependencies. In some cases, high-level infrastructure classes may depend on generic low-level classes. So that's the case where we have a high-level clock infrastructure wrapper, which depends on the low-level process infrastructure wrapper. So here, for example, a logging client might depend on a REST client. But yeah, I'm not sure if we're writing this test, we're testing the real version of both the clock and the process, and we're actually, yeah, not sure if we want to do this or not, but yeah. So I'm not quite sure how to work with high-level infrastructure wrappers, but yeah, let's leave this in for now because this shows that it actually works. So if I run this for real now, it's trying to change BG, which doesn't exist, and we can't see which background it's trying to use here. Yeah, okay. So the last thing I want to do, and the last thing I want to implement, is some refactoring to show the pattern better. So first off, so here we are back in the application. This is what we've got now. So first I would like to do a refactoring something like this. And this is going to be a refactoring towards this logic sandwich, this part right here. So first thing I want to do is to say something like image is afternoon, and down here I want to say image is morning, this should still pass, and now we can move that down there, should still pass. And now I want to move this part to a separate function saying get image and hour of day as an argument. And here we can do return. Oops. Like that. Invalid syntax. And now we should be able to do. Let's make it a bit more clear. Saying image is get image hour of day, and then say hour of day is self.clock get hour of day, and we can remove. Okay, let's remove that. Yeah, okay. So when we called get hour day twice, it would call process twice, and we only configured one response, so that's why it failed. So now this run method looks very similar to this logic sandwich. So first of all, we read data from infrastructure, we get the hour of day. Then we do process the input, get image, that's the logic. And then we change the image by calling the infrastructure wrapper again. So one further thing to do could be to do something like image selector, refactor that into class, and then here do something like image selector get image, something like that. And this image selector is the logic for that, for the application, and we can test that independently, and it doesn't depend on any infrastructure or anything. Just it's just a pure function, which is easy to test. We can do something like image selector get image hour of day 5. What should we get? We should get more, right? We can test this logic very easily here, and maybe let's add a test for an afternoon as well. So that will fail. Afternoon, something like that. So the logic of the application has now been extracted to this part right here, but we still have tests all the way with the infrastructure wrapper. So one thing that we can think about when we have this split is, do we actually need both of these tests in applications? We have one test for setting the background in the morning, we have one test for setting the background in the afternoon. Do we really need both of them? Because the application, if we look at the implementation, has no logic about what image to set. That logic is extracted to this class, so it's not the responsibility of the application anymore to make that decision. So one option would be to, let's just remove this test. Because that logic, the only difference between these two tests is the hour of the day right here. So we have 15 here and we have 9 in the test above. So I would say that logic is already tested at a lower level. So now when we only have this test, is there something that can fail? Yeah, I don't know. We still test that this command was run in the morning. So if we change this to afternoon, we get a test failure. So this is still an end-to-end test, and it's still testing everything. So this test is kind of duplicating the behavior of the logic. that we have down here. So if the logic changes, we will get 2 test failures. So let's say we should get warning 2 instead. So now we get 2 test failures, we should. Yeah, so the first one is in the logic test, and the second one is in this test right here. So one thing that we would like to do is to still have the end-to-end test, but not have this high-level test depend on this part right here. So one way we can do that is with the pattern right here, which is let's see, logic patterns, collaborator-based isolation. So what we could do instead is say, so first of all, I'm going to change this back. And here comes a limitation in doc test, so I will rewrite this test to be able to show this approach. So here we want to say instead that event equals this to be true. Right. So we want to assert that this are the events. And what we can do instead here, instead of saying warning here, we can say image selector get image where hour of day is 9. That should still pass. So in this test we just want to say, yeah, the image that we're changing to should be the, yeah, we just call this logic right here with the same hour of day as we pass in here. So now if we change this image, we should only get 1 test failure in the image selector, so only 1 failure. Because this test right here is getting the correct image because it's using the implementation of the image selector. So in this test we don't want to check that image selector works properly, we just want to make sure that the system works as a whole, and we only want to test the image selector logic right here in one place. So now when I did this, I'm thinking, what about this 9? It must be the same, right? How can we assert? Well, I mean, we could just. What if we do something like hard code the 9 there, and just ignore the hour of the day? Oh, okay, sorry. Let's revert this first. Right, back to passing test. And what if we down here, let's just hard code 9, so that this still passes. So yeah, this is another case where if we really want to do the end-to-end test, we need to test everything here. But again, this is like, are you confident with the tests or not? So hard-coded constant right here, it's obviously wrong to me, and yeah, I'm confident that this will work. But again, if you're not confident that that will work, you can write another test at a high level that tests the image selector as well. But yeah, the collaborator-based isolation, that the idea is to do something like this, as I understand it, so that this test doesn't depend on the details of the logic. So what else do we have that we can talk about? So we covered a bit the A-frame architecture. So this is kind of the structure of our application now. We have logic in one class, we have infrastructure in other classes, and we have the application class to glue this together in an A-frame architecture, in a logic sandwich, doing something like this. What else do we have? I think we did grow evolutionary seeds. That's kind of how we started. So here the first example is instantiate the application, render the application, and we get back a string. And eventually this will turn into my application taking a username service and username coming from this service instead. So it's starting with just returning constants and then fleshing out to infrastructures. It's kind of what we did in the beginning. Yeah, so this is my current understanding how to use this testing without mocks approach. And so this was an example how to do this from the beginning when you've got nothing. So another interesting thing to try would be to use this approach in an existing project where you just have to start with an existing code base. How do you introduce this pattern now? So that would be another interesting approach to try, and that's actually what they did in the video. So go check out Matt and James' video if you're interested in that, and I'll see you in 1 week.